let's talk about different categories for metals and ligands. And one way to categorize these is by their relative hardness or softness of the ligand or metal. Now, hard metals and ligands exhibit more ionic character in their bonding, and soft metals and ligands exhibit more covalent character when they're bonding. And when we have a hard metal bonding to a hard ligand, that's a very strong connection. When we have a soft metal bonding with a soft ligand, that is also a very strong connection. But if we were to bind a hard metal with a soft ligand, or a soft metal with a hard ligand, then that connection would not be as strong, and it would be easier to break. Now, what makes a metal hard or something hard? Well, in the case of metals, we would want a smaller, highly charged species. So, things like lithium plus is a hard metal just because it's very small, and although it just has a +1 charge, it's a high charge for the size of the metal. So we could write some lithium plus on here. The other thing that would make a metal harder is to have a high oxidation state, especially if it's +3. So if it has a high oxidation number, then it will be a hard metal, or it will tend to be hard. And the first row transition metal elements, especially when they're +3 charge, would fall under the hard metal category. Similarly, hard ligands are small and higher charged species. Things like fluoride or oxide. These would be particularly hard ligands, again because of their size and because of their high charge. Now, of course, there are other examples, but this is just to get you thinking about what would be a hard ligand, what would be a soft one. So let's talk about some of the soft metals. Soft metals would tend to be the larger transition metal elements, like the second and third row. And they would also be ones with a low oxidation number, or low oxidation state. Things like an oxidation state of 0 or +1, or even depending on how big the metal is, +2. So if you have a large metal such as mercury and you have the +2 ion, that's still quite soft just because the metal is very large. And then your soft ligands, there's quite a list of these, such as your halogens, especially, say, iodide. That's going to be quite soft. But to some extent, chloride and bromide are too. Some of the phosphine ligands, so a phosphorus, such as this phosphine ligand. Other phosphine ligands would also qualify. And then we have ligands that have double or triple bonds in them. So cyanide is one, and also ethene. So C2H4. And yes, this can bond to a metal. So these are some of the soft ligands. Now, when we're talking about traditional inorganic compounds, a lot of times we end up interacting with hard metals and hard ligands. And that's something that you're probably more familiar with just because that's the more traditional inorganic chemistry molecules. But when we start expanding our scope into organometallic, so when we start involving carbon and some of these other elements, then those interactions tend to be more covalent. Carbon likes to covalently bond. You might have figured that out by now. And so when we talk about organometallic complexes, they tend to be soft metals bonding with soft ligands, just because, again, the carbon ligand is generally soft. Now, you'll also notice that some of these ligands are neutral, as in they have no charge. Well, that also helps them be soft. So just to mention that. So it's useful to be able to categorize these just so that you can get a feel for how strong of an interaction we should expect between metals and ligands.